Hi everyone, in this video, we will share about the Intel 8086 microprocessor, which is one of the earliest microprocessor. Hope you will enjoy this video. First, what is Intel 8086?
8086 microprocessor was designed by Intel in 1976. Basically, 8086 microprocessor is an upgraded version of 8085 microprocessor. It is a 16-bit microprocessor with 20 lines of address and 16 rows of data. It can provide up to 1 megabyte of storage. Besides, it is also consists dominant set of instructions which are able to provide operations like multiplication and division easily. Two modes of operation are supported by 8086 microprocessor, which are maximum mode and minimum mode. Maximum mode is used when the system has multiple processors, while minimum mode is used when the system is having only a single processor.
Now, we will look at the features of Intel 8086.
There are some prominent features of 8086 microprocessor. First and foremost, 8086 microprocessor has an instruction queue which is capable to store 6 instruction bytes from the memory. Besides, it was the first 16-bit processor having 16-bit ALU, 16-bit register, internal data bus, and 16-bit external data bus. It can result in faster processing. Basically, this microprocessor have 3 versions and it is based on the frequency of operation, which are 5 MHz, 8 MHz, and 10 MHz. It is used to stage of pipelining, which are fetch stage, prefetch up to 6 bytes of instruction and storage them in the queue, and execute stage, execute instruction from the fetch stage. 8086 microprocessor also consists of 256 vector interrupts and 29,000 transistors.
Intel 8086 is the upgraded version of 8085. So, what is their comparison?
Comparison between 8085 and 8086 microprocessor. Size: 8085 is 8-bit microprocessor, whereas 8086 is 16-bit microprocessor. Address bus: 8085 has 16-bit address bus, while 8086 has 20-bit address bus. Memory: 8085 can access up to 64 KB, whereas 8086 can access up to 1 MB of memory. Instruction: 8085 doesn't have an instruction queue, whereas 8086 has an instruction queue. Pipelining: 8085 doesn't support a pipeline architecture, while 8086 support a pipeline architecture. I/O: 8085 can address 256 I/Os, whereas 8086 can access until 65,536 I/Os. Cost: the cost of 8085 is low, whereas that of 8086 is high.
Just now, we have heard about the overall of the microprocessor. So now, we will go to the architecture.
The architecture of Intel 8086 is divided into 2 units, which are bus interface unit and also the execution unit. First, the bus interface unit. The bus interface unit provides the interface of 8086 microprocessor to the external memory and also input and output devices via the system bus. The bus interface unit functions are including to generate the 20 bits physical address for memory access, fetch instruction from the memory, transfers data to and from the memory and input and output, and also maintain the seed byte prefetch instruction queue. The bus interface unit mainly contains of different parts, which are the instruction pointer, segment register, and instruction queue. Second, the execution unit. Several execution unit functions are to perform the logic and arithmetic operation on memory or register, receive the instruction from prefetch queue, and decodes it and store the information temporarily in the register array. The main component of execution unit are control circuit, instruction decoder, general purpose register, arithmetic logic unit or ALU, and special purpose register. Special purpose register have two flags register, which are conditional flag and also control flag. Conditional flags consist of carry flag, auxiliary flag, parity flag, zero flag, sign flag, and overflow flag, while control flag consists of trap flag, interrupt flag, and direction flag.
Now, we will look at the technology of Intel 8086 microprocessor.
Technology of Intel 8086 are pipelining, cache, and SIMD. For pipelining, there is multi-stage pipeline, pipeline execution, wasted cycles, superscala, pipeline stages, hazards, data hazards, control hazards, branch prediction, and multitasking. For cache, there are CPU memory gap, memory hierarchy, reading from memory, cache memory, caching in a memory hierarchy, general caching concepts, locality example, blocked matrix multiply performance, and cache-conscious programming. For SIMD, there are MMX instructions, saturation arithmetic, keys to SIMD programming, data-independent computation, application, other SIMD architectures, and impacts on programming.
Lastly, we will go through to the application of this microprocessor.
8086 microprocessor is used for general purpose, like it is used in traffic light signal for control purpose. It also used for small application like for calculator, scientific calculator, and small arithmetic operation.